All right, so here we go, guys. Day 3 of the semester 2 final review. Okay, so again, this is probably the hardest one of the day for today of our 10 problems that we're going to work on. So what you're supposed to do for these types of problems, if they want you to add things that have like different denominators, then what you have to do is find the common denominator. Okay, what denominator do they have in common? The least common denominator. So let's find this out by doing the following. First, I am going to factor my denominators just by taking out what they have in common. So the first one has an x in common, so I took it out. Right here, 1 over x plus 3, because those don't have anything in common. And then 2 over x times x plus 3, because those have an x in common. Okay? So, notice my denominators. Okay, look at my denominators. I got an x times x plus 3, an x plus 3, and then another one that says x times x plus 3. So if I ask you what's the least common denominator, the LCD, you have x times x plus 3, x plus 3, and x times x plus 3. I don't know if you guys remember, we used to do this before. Okay, now you have to grab everything that you see. So I see an x. All right, there's an x. What's the highest power on that x? Well, just a 1. So x goes there. The next thing that I see is an x plus 3. The highest power that I see from an x plus 3 is a 1. So that's my least common denominator right there. You always list everything you see to its highest power. Okay? Unless it's like numbers, like a 4 and an 8, then you got to think, what's the least common multiple for that? Okay? So here we go. This is going to be the annoying part of this problem. I do apologize, but let me just write this out. Actually, hold on. Let me not do that right here. What I'm going to do is I'm going to get all of this and multiply it times x plus 3. But the next step is going to be kind of long. But remember, I always used to do this step. It was a long step, but it helps us see what we can cancel, okay? So here we go. X times x plus 3 times 1 over x times x plus 3 plus, I'm just distributing it, okay? X times x plus 3 times 1 over x times x plus, 1 over x plus 3 equals x times x plus 3 times 2 over x times x plus 3. And what you want to do is look at what you're multiplying by, the x times x plus 3, and ask yourself, can I cancel stuff below? Do they have things in common? This one right here that I'm circling, is there anything in common from top to bottom? Like, what can I cancel out? All right, the whole thing, right? All of it. So what's left? 1. All right, I like that. What about the next one? What can I cancel? X plus 3. So what's left? 1x or just x. What can I cancel on the next one? All right, so what's left? 2. And look at how nice it turned out. I just got to solve that. That's easy. Just subtract 1 and I'm done, right? So let's do minus 1 on both sides. So x equals 1, and I'm done. Remember, these problems are complicated, but if you do the right steps, it'll break down real nice and easy. It's not going to be anything that's going to be really hard to do. You just got to make sure you take the right step. So I'm showing you the right step is to multiply by your LCD and cancel stuff out. Okay, just cancel stuff out. Any questions on this one? Again, this is probably like the hardest question of the day. All right. So determine if the sequence is geometric. If it is, find the common ratio. Okay, so determine if the sequence is geometric. I mean, if you want to just abbreviate, just say.
Something went wrong. Please try again.
There you go. That's determine if the sequence is geometric. And is it a common ratio? So you could just say like, is it geometric? Find R. Okay, that's a faster way to put it. Okay, so the numbers we got are 200, 150, 25. To find the common ratio, we have to divide. Okay, and we're going to divide the numbers in that order. Okay, so we have to divide. So 100 divided by 200. Well, that's half. 50 divided by 100. Also half. 25 divided by 50. That's half. Okay, so are all those fractions common? Are they the same? Yeah. So these are common ratios. R equals half. It does have a common ratio. If they're all the same number, then it is a common ratio. They ask us if it's geometric, so I'm just going to write yes right here because it is. It's geometric and the common ratio was half. Remember, with the geometric, the common ratio you have to divide. With the arithmetic or the arithmetic sequences, you have to find a common difference. So you're going to subtract. And that's what we're going to do next right now. A common difference. So here is number 23. It says determine if the sequence is arithmetic. If it is, find the common difference. Or is it an arithmetic sequence? Find the letter D. D equals something, right? Common difference. So is it an arithmetic sequence? Find the common difference if it is. So we're going to do the same exact thing we did in the other problem. I'm going to draw my arrows here. That's a comma there, not a 30. But this time, instead of dividing, I'm going to subtract. Okay? So 13 minus 3. That's 10. 23 minus 13. That's also 10. 33 minus 23. That's also 10. So all those numbers are the same. That makes them common. And since I subtracted, it's a difference. So the common difference is 10. So I'm going to put a box around this because that's my answer. I'm just going to put yes, that it is an arithmetic sequence. Okay? So not normally too hard to do. Just got to figure out the difference there. All right. Now this is going to be the toughest problem for us to do of logs for today. They only get easier from here on out. Okay? But before I do this, I got to show you guys some properties again, just in case you don't remember. Okay? In case you don't remember, I'm going to zoom out a bit. And let me show you some properties you're supposed to know. All right. Log base b of x plus log base b of y is log base b of x times y. So if you have two logs adding together, it results in a multiplication. Okay? So you're going to keep the same base, but it's going to become a multiplication. That's one property you're supposed to know. Next property. Log base b of x minus log base b of y is log base b of x divided by y. If you want to do word association, just remember, subtraction means fraction. Okay? For the top one, summation, multiplication. Okay, so if you're adding, you multiply. So summation is multiplication, subtraction is fraction. Okay? So those aren't the only ones you have to know. There's a lot of these. So let me show you a couple more. If there's a number in front of your log, then that number becomes a power. Or if there's a power, you can bring it down in front. Okay? But that's another property you guys have to know. If there's a number in front of your log, then that number becomes a power. If you take the log base b of b, so notice the base and the main number match, then your answer is 1. There's one more I got to show you. Okay, the last one is this. If you're solving an equation and now you have logs equal to each other, so log base b of x equals to log base b of y, that implies, let me put little dots here so you guys can see these properties. That implies that x can be set equal to y. Because we're actually going to use that in this problem that we're doing. So these are all the properties that they expect you to remember, right? No problem. Obviously not always true. Okay. I have people I know that only memorize math for tests, and after that test is over, it all just disappears. Right? And then I also have some people I know that will memorize the math and they never forget it. The difference? Some people feel like math is important for their career, so they remember stuff. Other people are like, I'm never going to use this again. What do I need it for? And they forget it. I'm not mad at either one. It's fine. Whatever. Use the math for whatever you need to. Okay? So if you remember these already, great. If you don't, make sure you write them down on a note. Okay? Somewhere. Remember, you have 2 pages that you can use, front and back. So make sure you guys write them down somewhere. So let's get back to these log things. That way we can finish them up. So notice the first part, log base 3 of x plus 2 plus, right? There's a plus right here. Log base 3 of 5. The plus, the summation means multiplication. Right? I'm going to multiply. So I'm going to write log base 3 of 5 times x plus 2 equal to log base 3 of 20. Because I'm going to get the 5 and the x plus 2 and I'm going to put them together. Now, I'm on the last property right now. You see I have a log base 3 equal to a log base 3? That means I can get the inside parts and put them equal to each other. So this is 5 times x plus 2 equal to 20. Now, you could either divide by 5 or distribute. What would you guys like me to do? Distribute it or divide by 5? What would you guys prefer? Either one's good. Distribute? Okay, most people distribute. Okay, some people divide because they're like, oh, that'll make it faster. But whatever. Do whatever makes you feel comfortable. So I'll subtract by 10. That gives me 5x equals to 10. What's my answer? What's x equal to? 2, right? So there you go. Okay, so there's your solution for that. Bless you. If you would have divided by 5, you would have gotten x plus 2 equals 4, and then if you subtract 2, you get 2 anyway, so it still works. Okay? So, all right, that's like the hardest log problem that we have, at least up to now. Okay? This one not as difficult. Okay? Log of negative x plus 1 equals log of 3. Notice there's no base, so what's my base supposed to be? A 10, right? It has to be a 10. If it's not there, it's a 10. Do you have to write it down? No. But if you wanted to, you could say base 10. And that's okay. But you don't have to write it down. Notice how it's already log base 10 equal to log base 10. So all I have to do is just get negative x plus 1 and set it equal to 3. And then just solve. So we'll subtract 1. So negative x is equal to 2. And then we'll divide by negative 1, which gives me x equal to negative 2. All right. So not too bad. All right. The other one was a little tougher because we had to combine stuff first and then create our equations. So for this, there are two little things I want you guys to know on the side, okay? You see how this has the power or the variable as a power? That means I got to bring that power down. The way you bring powers down, you can do it two ways. If you have like e to the x, if you introduce a natural log to it, if you put ln, then your answer is just x. Okay? Now, if it's not an e, let's say ln of 2 to the x, then your answer to that will be x ln of 2. Okay? Now, if you're wondering, why didn't the other one have x ln of e? It actually did, but ln of e, if you put it on your calculator, it equals 1. So it goes away. Okay? So those are two little properties for you guys to know. So if I subtract 5 on both sides, I get e to the k equals 70. So I'm going to introduce natural log on both sides. So ln of e to the k equals ln of 70. Okay, so on the left side, what's left? What, the k, right? And on the right side, well, I got to use my calculator. So let's see. Let me turn this on. So we're just going to do ln of 70. So that's a 4.25. 4.25. So 4.25, and I'm done. Okay, this next problem is very similar. Solve the equation 5 to the x plus 3 equals 23. We're going to move that 3 out of the way. We're going to try to get that x variable down by using natural logs, okay? I'm just giving you guys a little bit of time to write that down. So here we go. Let's subtract 3. So 5 to the x equals 20. Now when I do the natural log right here, okay, for both of these, on both sides, ln of 5 to the x equals to ln of 20. The x is going to go down, but the ln of 5 is not going to disappear. It's going to be x ln of 5 equals ln of 20. Now to get x by itself, I'm going to have to divide both sides by natural log of 5. So let me do division . So let me just get on my calculator really quick. What's ln of 20 divided by ln of 5? I actually have it up there, right here. Ln of 20 divided by ln of 5 is 1.86. 1.86. So these aren't that hard to do. You just got to remember natural log and then what happens as you do it. All right, we got one more of these and then 2 of expansion condensing and we're done, okay? So 3 more to go. This is the easiest one because the other ones don't really have that much to do in this problem here. 6 to the x equals to 50, okay? I don't have to add or subtract anything. It's already set up. I'm just going to do the natural log on both sides. So ln of 6 to the x equals ln of 50. Well, that allows the x to drop to the front, so it's x ln of 6 equals ln of 50. Divide both sides by ln of 6, okay? When I do that, ln of 50 divided by ln of 6, The answer is right here. Ln of 50 divided by ln of 6 is 2.1833. So 2.18. And there's my solution. All right, the last two problems, we don't have to solve for anything, but they want you to rewrite stuff. Whoops, sorry about that. That one right there. You don't have to write the whole top part, just say condense the log if you want. Condense the log. They want you to get all of that and make it into just one term that says log base 2 of something. So just condense the log. So 2 log base 2 of 5 minus 3 log base 2 of 10. So notice there are some numbers in front of the log. Okay, there's some numbers in front of the log. So what do I do with those numbers in front of the log? Where do they what do they become? They become powers. Yeah, you got to move them up. So my first step is to write log base 2 of 5 squared minus log base 2 of 10 to the third. Now, on your quiz, they are not going to want you to expand those. So they don't want you to write 5 squared is 25, 10 to the third is 1,000. They don't need you to do that, okay? They just want you to leave it the way it is, okay? So what happens if two logs have a subtraction? What does that result in? A division, a fraction, right? We should have a fraction from subtraction. So log base 2 of a fraction. On top, I put 5 squared. On the bottom, 10 to the third. And you're done. That's all you got to do. Just condense it. Make it into one log function. Okay. Last one. Blow this one up, okay? Expand it. You're going to have to expand it. Log base 5 of 3 squared over 5 to the fourth. So we're kind of going backwards. So I see a fraction, so what should it become? Subtraction, right? So let me go ahead and do that. Log base 5 of 3 squared minus log base 5 of 5 to the fourth. Now I notice powers. So what do I do with my powers? Yeah, bring them to the front. Make them numbers in the front, right? So I get 2 log base 5 of 3 minus 4 log base 5 of 5. Now normally you'd be done, but what is this? That's a 1. Yeah. Because remember, if the base and the main number match, it's a 1. So 4 times 1 is 4. So this is 2 log base 5 of 3 minus 4. And that's it.